Just looking at our previous kind of, when I was sick, I gave you guys a sheet that you went through. We practiced some of this review stuff, and we didn't do as well as we hoped, right? I think my goal is that 70% of you would get 70% or better, and we had 3 of you get 70% or better, okay? So let's talk about, you're going to retake that one, and we will retake it again and again and again until finally we have at least 70% of you achieving 70% or better. So here's the type of questions that you're going to be asked. Let's make sure we know how to do them. Limit as x goes to 1 from the left. It is 4. Limit as x goes to 1 from the right. It is -2. Limit as x goes to 1. Why does it not exist? They're not the same. What is f of 1? It is 4. How about as x goes to 6 from the left? From the right? The limit as a whole? And f of 6? It is 2. Yep. So you must be able to handle limits graphically. That's not the way the AP question will be designed. I'll show you the way the AP question will be designed here in a little bit. But first it says evaluate the following limits algebraically. So there will be sections on your test where you have to use your calculator and sections where you work by hand. So you may use your calculator to confirm your answer. That was just when we were doing it, but you really can't do that. So limit as x goes to 2. What would you do? You would factor? Good. So we have limit as x goes to 2 of what? X squared minus 4 over x and x squared plus 4 over x minus 2. And that factors, doesn't it? X minus 2 times x plus 2. X squared plus 4 all over x minus 2. The x minus 2's do go away. Plug in what? 2. And you get 4 plus, or 4 times 8, which is 32. What's an easier way to do the problem? Anybody? If you plug in 2, what do you get in the top? 0. If you plug in 2, what do you get in the bottom? And if you get 0 over 0, what can you do to determine a limit? L'Hopital's rule, very good. That says you take the derivative of the top, which is 4x cubed over a derivative of the bottom, 1. And then you plug in 2, and you can see you get 4 times 8, which is 32. L'Hopital's rule works. It's pretty cool. Yep, that's why we're reviewing it. Next one, a little bit more difficult because the derivative does not work so well in this situation. But let's look at this. Limit as x goes to -2. Notice if you plug in -2, you get the square root of 9 minus 3 over 0, or 0 over 0. L'Hopital's rule would work, but a lot of people make mistakes in taking the derivative. I would encourage you to take an algebraic approach. Square root of 11 plus x minus 3 over x plus 2. What are you going to do to determine that limit algebraically? Multiply by the conjugate. Root of 11 plus x plus 3 over root of 11 plus x plus 3. And as we multiply these, root of 11 plus x times root of 11 plus x, you get 11 plus x. And then -3 times +3, -9. And on the bottom, you have x plus 2 times that quantity, root of 11 plus x plus 3. So what do you get in the top? X plus 2, what do you get in the bottom? X plus 2 times all that, what can you do? Cross off the x plus 2's, right? Can I now plug in the negative 2? Yeah, and you get 11 plus negative 2 is 9. Square root of 9 is 3, plus 3 is 6, so you get 1 over 6. 1/6 is the correct result. What I'd like you to do is I'd like you to take out your calculator and see if by using your calculator in any way, shape, or form, see if you can come up with the limits for 3a and 3b. Go. That's a tough one. The lining thing?
Yeah. Oh. So that was my problem. I'm trying to figure out the same.
You go to math and you go to numbers and all sorts of stuff.
Okay. Oh my god.
I hope that for the first one you got this shape right here by zoom. I'm going to just choose a zoom as a decimal because I know how this works out. Notice I get that shape. So as x goes to negative 3, what's the limit? It does not exist because it has to be the same from the left as it is from the right. From the left it's 1, from the right it's negative 1. I'm sorry, from the left it's negative 1, from the right it's positive 1, so therefore it does not exist. Whereas if I look at the next one, I have y is equal to absolute value. Nope, we're going to go with this one. So check that out. And I look at this graph, and it looks like as x goes to 2 from the positive, what does the y value go towards? Negative infinity, okay? So that's a nice basic introduction into your limit ideas. Let's talk a little bit more about limits and continuity. Please turn to your other sheet that looks like this, okay? So in order for limits to exist, tell me something. The limit as x goes to a from the left must equal the limit as x goes to a from the right. The right side must be the same as the left side. If that's not the case, then the limit does not exist. You can definitely have limits if it's discontinuous. I'll give you a couple examples. Here, the limit is positive infinity. It's discontinuous, yet the limit exists. Another example would be right here. Notice we have discontinuity. Open hole does not mean that the limit does not exist. In fact, every single derivative that you take at a point ends up with a graph where you have an open hole. A limit definitely does exist in those situations. Okay. What kind of graphs are continuous? Describe a continuous graph. Yep, draw without picking up pencil. Good. We had three criteria for continuity to be met. Number one, f of a exists. Do you remember the other two? The limit as x approaches a of f of x must exist. Remember the third? The two must be equal to each other. So the limit as x goes to a of the function must be equal to f of a. So if those three are true, then it definitely then it's continuous. Those are elements of continuity. I know you don't remember them, but they should look familiar that we did tests on them and you had to determine them. Those are second or first tests of the year. So it was a long time ago. And then 3, differentiable. In order for a function to be differentiable, the derivative from the left is the same as the right. So your derivative from the left must be the same as the right. Can you give me 3 examples where you cannot take a derivative? Corner, good. So can't take a derivative at a corner. Somebody else remember one? Where you have a vertical tangent. And then where it's discontinuous. Any type of discontinuity, you can't take a derivative. Okay, so we're going to set our timer here. When I say go, you're going to do this first problem here. So this is straight from the AP exam. It's from 2012. If you can use your calculator, it'll say calculator next to it. If you can't use your calculator, then you won't see anything next to it. But you'll do that problem, and then you'll do this one and this one. So that's 3, and then 4 and 5. So we're going to set our timer for 7 minutes, and you will do your best. On your mark, get set, go. I didn't look at it ahead of time. I respect people's privacy, unlike the government. So Henrik, when do we start prosecuting Putin for war crimes? We would have to go through the UN, right? And so what's the point of the UN then, you know? Yeah. Nothing practical. The AP exam not only tests your ability of calculus, but also your level of reading comprehension as well. It's going to be a fair amount of reading. I believe in you. You can do it, Freddie. Pre-meet practice type stuff. So we'll shake our legs out from the weekend, make sure people have marks on some handoffs, some starts. Hurdlers are going to get a go at things. Go over lineup. We have to move the pit because tomorrow the wind's going to come from the south. So both high jump and pole vault pits have to be moved. Hurdles set up for the meet. All sorts of stuff. We are looking at 47 degrees and 20-mile-an-hour winds and rain. So Mr. Durbin will be making a call by 2 p.m. tomorrow. Tomorrow is Leon's birthday. Jacob is not showing up for Leon's birthday. Oh, we still haven't celebrated it. Oh. All right, Beige coming up on the 6th. Exciting. Looks like people are close to finishing up here. Can I give you another minute and then have you finish? Is that enough?
About the ACT. That's what I think that is very
Give you another 45 seconds. Today? Yeah. Sure. Okay, let's stop there. Okay, just to give you guys an idea about timeline, I believe this is about where we're at. So you're going to start off with 27 problems in 45 minutes on the exam. That's about 1:40 per problem. So I give you about 6 minutes there for 5 questions. So you're ahead of the curve in terms of time level. And then you would have about 2.5 minutes for 18 problems. Again, you get another 45 minutes. So 45 minutes and 45 minutes. You'll get no calculator, and then you'll have a calculator for this section. You'll then take a break, and you'll come back for the free response section. You'll have 2 questions that require a calculator. That's a total of 30 minutes there. And then you'll have 4 that have no calculator. That's a total of 60 minutes there. And so 15 minutes apiece for those questions. Looks like I've got. Total front to end, you're looking at about 3.5 hours. So, yep. Yep. Okay, the graph of the function is shown. Which of the following statements is false? Limit as x approaches 2 exists, and that is true. Limit as x approaches 3 exists. That is true. As x approaches 4, that does not exist. So letter C is false. Okay, my computer doesn't want to work right now. Here we go for the next one. Okay, there we have it.
Oh, man.
Okay, which of the following statements is true? Limit as x approaches 2 from the left. Yes, that does exist. Limit as x approaches 2 from the right. Yes, that is true. The limit as x approaches 2, that does not exist as a whole, so it would be 1 and 2 only. Okay, for number 3, we have which of the following does limit x equal 4 exist? It is true for 1, it is true for 2, it is not true for 3. So 1 and 2 only, so again you have letter D. Okay, my smart board is really struggling right now. We're going to do our best. If the limit as x goes to 3 of f of x equals 7, which the following must be true, does it have to be continuous in order for a limit to exist? No, not at all. Again, we brought up the examples before. That is not continuous, and yet a limit exists. Does it have to be differentiable for a limit to exist? No, you could have that situation. The limit could exist, but it's not differentiable. Limit definitely exists there, but it's not differentiable. Do you have to be able to plug in a value and get the limit? No, you don't. As you can see right here, if you plugged in a value here, you would not get the limit. So, in fact, none of these need to be true in order for that to be the case. Multiple ways of going about this next one. I'm guessing that most people factored out x squared. Is that the case? Otherwise, you could use L'Hopital's rule. But if you factor out x squared, you should get 5x squared plus 8 over x squared times 3x squared minus 16. And notice how those cancel. You plug in 0, those go away. You should get negative 1/2. And so that's that. Let's talk about some derivatives. You've now done limits. We move on to one of the bigger pieces, which is our differentiation. So suppose f of x is equal to x to the nth. What is the derivative rule? F prime of x would be what? N times x to the n minus 1. Suppose you have f times g and you want to take the derivative. What do we call that? The product rule, which is f prime g plus g prime f. Suppose you have f divided by g. What is that derivative? All over g squared. Good. Chain rule, you know how to set that up, right? Okay. So what about our trigonometric derivatives? Let's just talk about them. Derivative sine. Cosine. Derivative cosine. Negative sine. Derivative tangent. Secant squared. Derivative. A lot of you guys got that wrong on the last test. Derivative of cotangent. Negative cosecant squared. Derivative of secant. Secant times tangent. Derivative of cosecant. Negative cosecant cotangent. How about the derivative of e to the x? Derivative of natural log of x. Derivative of arc sine. There. How about the derivative of arc secant? 1 over x times the root of x squared minus 1. Very good, Colin. Totally what you were going to say. And how about the derivative of arctangent of x? We generally raise 1 plus x squared. So it is not very often I see one of those listed as an example on the AP exam. All the other ones we talked about, those are absolute musts. You do not want to get a question wrong because you can't remember that the derivative of tangent is secant squared. Okay? You don't want to get that one wrong. When they put that on the test, that's like a, thank you, it's Christmas. You gave me one that I know. Okay? So you got to know those. Those are fundamental. So, good. You got the derivatives. Let's flip back to that previous document and let's take some derivatives together. So this is 6x to what power? Yeah, to the 2/5. So if you're going to take the derivative, f prime of x is going to be what? What's that? Yeah, 12/5. Good. So 12 over 5, x to what power? Negative 3/5. So in other words, 12 over 5, x to the 3/5. Again, please get that one right on the test. This one I rewrite as what? How do you rewrite that? X to the negative 7th. Good. So what's the derivative? Negative 28 over 5, x to the negative 8th. Or negative 28 over 5, x to the 8th. And for this one, I'll just rewrite 3x to the 3rd as a 3x to the negative 3rd. So what's the derivative of 6x squared? 12x. What's the derivative of 4? 0. And the derivative of 3x, it looks like it's a negative 3x to the negative 3rd, excuse me. Plus 9 over x to the 4th. Good. So just try to get through this piece. Let's finish here, and then you can go on your way. So I'm given a table of values. This is not written as an AP question, but this is definitely an AP question. I want to find f times g prime of 8. So what rule will you use? Product. So you do f prime of 8 times g of 8. Then what? Plus g prime of 8 times f of 8. What is f prime of 8? Negative 6. What is g of 8? Negative 3. What is g prime of 8? 1. And what is f of 8? So we get 18 plus 2 is 20. We'll start with 5b tomorrow. We have to try to keep a good pace, otherwise we could review for 2 months. So we'll do our best. Make sure you have your stuff ready to go. And we wish the very best to our friend Jacob. And Jacob, if you finish the ACT early, which you actually might be able to be back in class for a little bit, will we take him if he comes back to class? Does he need to do the chicken dance if he comes back? Probably. Oh, it's not happening. All right, then you're not coming back.